and it is called as a normal curve. So in a normal curve, so first let's see the history. The normal curve was developed mathematically in 1733 by de Morgan as an approximation to the binomial distribution. This paper was discovered in 1924 by the Carl Pearson. Laplace used the normal curve in 1783 to describe the distribution of errors. The normal distribution is the most used statistical distribution, and the principal reasons are: normality arises naturally in many physical, biological, and social measurement situations, or normality is important in statistical inference. Subsequently, Gauss used the normal curve to analyze the data in 1809, and the normal curve is often called as the Gaussian distribution curve, or simply the Gaussian distribution. The term well-shaped curve is often used in everyday usage. Normal moment. The normal distribution is characterized by two parameters, the mean and the standard deviation sigma. The mean is a measure of location or a center, and the standard deviation is a measure of scale or a spread. The mean can be any value between infinity and the standard deviation, and it must be positive. Each possible value of mean and the sigma defined as a specific normal distribution, and collectively all the possible normal distribution defined as a normal family. Each possible value of sigma defined as a specific normal distribution, and collectively all possible normal distribution defined as a normal family. So in normal curve, the area between one standard deviation on the either side of the mean will include approximately 68% of the value, and the area between two standard deviation on the either side of the mean will include approximately 95% of the values, and the area between three standard deviation on the either side of the mean will include approximately 99.7% of the value, and the limit on the either side of the mean are called as confidence limit. Now, what is standard normal distribution? The standard normal distribution is a special member of the normal family that has a mean of 0 and standard deviation of 1. Standard normal random variable is denoted by Z, as we discussed later. The standard normal distribution is important since the probabilities and the quantities of a normal distribution can be computed from the standard deviation distribution. There might be many normal curves, but there is only one standard normal curve. Normal curves can be many, and standard normal curve is one. The standard normal curve is a well-shaped. The curve is perfectly symmetrical based on the infinite large number of observations. The maximum number of observations is at the mean, and the number of observations gradually decreases on either side, and few observations are at the extreme points. The total area of the curve is 1, its mean 0, and the standard deviation is 1. If the number of sample is large, then the value may be grouped as done in frequency distribution table, and it seems that the sample follow a normal distribution curve. You can see in this graph, which is showing below, the shaded area of the normal curve represents 5% of the distribution. That is 95% of the observation fall between the score of 1.96 and plus 1.96, and puts another way, 5% of the observation fall outside this range. So what are the odds for obtaining a score either below this value? And odds are 95 out of 100 that the score will be within 1.96, that is range minus 1.96 to plus 1.96. Therefore, the odds of a score being outside that range are 5 in 100. And we prefer this situation as having the probability of less than 0.5 and use the expression p-value that is less than 0.5 to indicate the probability of the occurrence. Population value of standard deviation limit includes 68% of the sample value in fairly large number. Just an example. Range of a population value this much of standard deviation include 99% of the estimate, hence an estimate higher or lower than that will be obtained in 1% of cases, and this is a very rare case. Now, what is test of significance? These tests are mathematical method by which probability, which is denoted by P or relative frequency of an observed difference occurring by chance, is found. It may be difference between the mean or a proportion of a sample and a universe, or between the estimates of an experiment and the control group. So what is test of significance? A statistical procedure by which one can conclude if the observed result from the sample is due to chance or not. When different samples are drawn from same population, the estimate might be differ. This difference in the estimate is called as the sampling variability. Hence, while dealing with estimate from two or more samples, one is interested to know whether the difference in the value of estimate between the group are due to sampling variation or not. So the test of significance deals with the technique to know how far the difference between the estimate of a different sample is due to the sampling variation. So what actually are the tests of significance? For example, we see if two questions arise about any hypothesized relationship between two variables. First, what is the probability that the relationship exists? And if it does, then how strong is the relationship? So what is the probability that that relationship exists? Or if it exists, then how strong is that relationship is? So there are two types of tools that are used to address this question. First is addressed by test for statistical significance, and the second is addressed by the measure of association. The test of statistical significance are used to address the question, what is the probability that what we think in relationship between two variables is really just a chance occurrence? If we selected many samples from the same population, would we still find the same relationship between these two variables in every sample? If we could do a census of the population, would we also find that this relationship exists in the population from which the sample is drawn? Or is our finding is due to any random chance? Test for statistical significance tell us what the probability is that the relationship we think we have found is due to any random chance. They tell us what the probability is that we could be making an error if we are making any error, or we assume that we could found that relationship exists. We can never be completely 100% certain in that relationship exists between the two variables. There are too many sources of error to be controlled. For example, sampling error, researcher bias, problem with the reliability and validity, and the simple mistakes can happen, etc. But using probability theory, the normal curve by using the probability theory and the normal curve, we can estimate the probability of being wrong. If we assume that we are finding a relationship is true, and if the probability of being wrong is small, then we say that our observation of the relationship is statistically significant finding. Statistically significance means that there is a good chance that we are right in finding and a relationship between two variables exists. But statistical significance is not the same as a practical significance. We can have a statistically significant finding, but the implication of that finding may have no practical application. The researcher must always examine both the statistical and the practical significance of any research finding. Let's take one example. We may find that there is statistical significant relationship between the citizen age and the statistical significance with the city recreation services. It may be that older citizens are 5% less satisfied than younger citizens with the city recreation services. But is 5% of a large enough difference to be concerned about? We have to find the statistical significant relationship between the citizen age and the satisfaction with their services. Oftentimes, when differences are small but statistically significant, it is due to a very large number of sample size. And in the sample of a smaller size, the difference would not be enough to be statistically significant. There are some steps in testing the statistical significance. First, we have to state the research hypothesis. Then we have to state the null hypothesis. Then we have to select the probability of an error level, that is alpha level. Then select and compute the test of statistical significance and then interpret the result. Now, focus on the first step, that is research hypothesis. A research hypothesis states the expected relationship between the two variables. It may be stated in general terms or it may include the dimension of a direction and magnitude. For example, general, the length of the job training program is related to the rate of a job placement of a trainees. Direction, the longer the training program and the higher the rate of job placement of a trainees. Magnitude, longer the training program will place twice as many trainees into the job as the shorter the program. General, the graduate assistant pay is influenced by gender. The direction, male graduate assistants are paid more than female graduate assistants. And magnitude, female graduate assistants are paid less than 70% of what male graduate assistants are paid. Now, second step is null hypothesis. We have to state the null hypothesis. What is null hypothesis? Null hypothesis usually state that there is no relationship between the two variables. For example, there is no relationship between the length of the job training program and the rate of a job placement of a trainees. Graduate assistant pay is not influenced by the gender. A null hypothesis may also state that the relationship proposed in the research hypothesis is not true. For example, longer trainee program will place the same number of fewer trainees into the job as a shorter program. The female graduate assistants are paid at least 75% or more of what male graduate assistants are paid. Researcher uses null hypothesis in the research because it is easier to disprove a null hypothesis than it is to prove a research hypothesis. A null hypothesis is the researcher's straw man. That is, it is easier to show that something is false once than show that something is always true. It is easier to show that something is false than to show that something is always true. It is easier to find the confirming evidence that against the null hypothesis than to finding the confirming evidence for the researcher hypothesis. For research hypothesis. Now, what is type 1 and type 2 errors? Type 1 and type 2 errors. Even in the best research project, there is always a possibility that the researcher will make a mistake regarding the relationship between two variables. There is always a possibility of error. So there are mainly two possible mistakes or error, that is type 1 error and type 2 error. What is type 1 error? This error when researcher assume that a relationship exists when in fact the evidence is that it does not. And in a type 1 error, the researcher should accept the null hypothesis and reject the researcher hypothesis, but the opposite occurs. And the probability of committing a type 1 error is called as alpha. So the probability of committing a type 1 error is called alpha. And type 2 is beta. Let's see what is type 2 error. This occurs when the researcher assumes that a relationship does not exist when in fact the evidence is that it does. In a type 2 error, the researcher should reject the null hypothesis and accept the research hypothesis, but the opposite occurs. The probability of committing type 2 error is called as beta, and the probability of occurring type 1 error is known as alpha. So in short, type 1 error is known as alpha and type 2 is known as beta. Generally, reducing the possibility of committing a type 1 error increases with the possibility of committing type 2 error. Reducing the possibility of committing a type 2 error, increasing the possibility of committing a type 1 error. Okay. In this example, which type of error would you refer or commit? Let's see the research hypothesis. The new drug is better at treating heart attack than an old drug. It's just an example. Then what is null hypothesis? The new drug is no better at treating a heart attack than a old drug. This is the null hypothesis. Research hypothesis is new drug is better at treating the heart attack than the old one. And the null hypothesis, the new drug is no better at treating the heart attack than the old one, the old drug. And if type 1 error is committed, then the new drug is assumed to be a better than when it really is not. And the null hypothesis should be accepted, but it is rejected. And people may be treated with the new drug, and when they would have been better off with the old one. And what is type 2 error? If a type 2 error is committed, this is type 1. And when type 2 error is committed, then the new drug is assumed to be no better when it's really better. And the null hypothesis should be rejected, but it is accepted. So people may not be treated with the new drug, although they would be better off than with the old one. So in this example, which type of error would you commit? Sorry. Okay. Then comes a test of significance. There are various tests of significance. It is standard error of mean, standard error of difference between two mean of a large sample, and standard error of proportion, standard error of difference between two proportion, chi-square test, and student t-test. Now, first of all, what is standard error of mean? Standard error is a measure of chance variation, and it does not mean error or a mistake. It is denoted by this formula. Therefore, standard error of a mean is a standard deviation of a sample divided by the square root of the number of observations in the sample. This is the formula. Consider a situation where we take many samples and determine a mean and standard deviation for each sample. The obtained mean value would be distributed in the same normal distribution or a raw scores. Consider the illustration. This is just an example. So you could also apply the same normal curve graph to the mean as was applied to the individual score. This is an example. So standard error of a difference between two mean is given by this formula. This is the how we have to calculate. You have to learn this formula. Now comes a chi-square test. Chi-square is a non-parametric test. There is two type of test, parametric and non-parametric. So chi-square is a non-parametric test of statistical significance and is also known as a cross break. An appropriately performed test of statistical significance lets you know the degree of confidence you can have in accepting or rejecting an hypothesis. Chi-square is used most frequently to test the statistical significance of a result. Reported in vibrant table and the interrupting the vibrant table is integral interpreting the result of chi-square test.